David Maliniak at CES 2020. I am with Maha Achour. Maha is the CEO of Metawave, and she's going to tell us about technology for greater safety on the ground and in the air. Thanks for joining us, Maha.
Thank you, David. Pleasure to meet you.
Sure. So tell us what's going on.
Okay, so we all love our cars. We all love the ABS, automatic braking, and line keeping. So these are all great for safety. Why? Because especially new drivers, they're always looking down on their phone.
Yeah.
So how do you really, we cannot prevent this from happening for sure. So how do we really keep those roads safer? And also how do we transition to next level of mobility in general? So number one is sensors. You can do a lot of things with AI and perception, what is called in the sensor fusion or the software stack.
Yeah.
But at the end, if you don't have the proper sensors around you to sense your environment,
The hardware.
there is nothing you can do with the zeros and ones, right? And what Metawave has done from the beginning is that we adopted a technology that the military has been using for decades, which is phased array radars. Of course, they build it at lower frequencies because of the longer range and also the extremely higher cost. These radars cost $500,000 at least.
Yes.
So how do you bring that technology to the consumer market? How do you bring it to the Teslas, all these emerging EV cars that needs to monetize on these vehicles when they are sold? Combustion engine vehicles, the return on investments takes time because every time you go to the service company, they get some money back from these vehicles. But EV cars only have the tires and the brakes, that's it.
Yeah.
So what we call software-defined vehicle, which is pushing new software, enabling a hardware that is ready for all these software upgrades is very critical.
Yes.
Elon Musk, of course, had this in mind very early on, but of course he oversold that image, and now I think everybody realizes that it's FSD, so we all know starting January 1st, they cannot promote FSD since we all know that the cars today do not support it. Do not support it. Why? Because it cannot operate in very bad weather, it cannot operate in very dark environment, it cannot operate when you have very dense clutters, especially at night. So this is where the radar basically shines. And the radar always has been the main sensor that the defense industry relies on. They don't rely on cameras, they don't rely on LiDAR. They're just trying to bring the LiDAR to understand what it is, but optical sensor, they have limitations. Mainly the range. Optical sensors, they cannot propagate very long distance unless you blast it with very high power laser. Eye safety, power consumption, cost, all of this becomes a challenge. So Metawave is the only company that basically made that radar possible. So here you have some of our chips. So the small ones you see here is the 77 gigahertz chip, the Marconi chip. This is the first 77 gigahertz chip that enables these phased array, analog, beamforming radar capabilities today. And as you can see here with some of those data that is collected on the road with this radar, so this is the Carson radar that we developed. We are not a tier one, so we really don't mass produce radars, but what we do, we develop the missing components.
Right.
And we build a radar based on these missing components with all the software around it to make sure we optimize the performance and deliver to our customers a solution, a full solution, from an architecture to the blueprint and so forth.
Yeah. I was going to ask you,
Yes,
it's all 77 gigahertz?
Yeah, so what you see here is the 77 gigahertz.
Yeah.
Now, let's talk a little bit about air mobility. Let's talk a little bit about the drones. Let's talk a little bit about cargo delivery drones. As you know, all these urban, the urban air mobility or the aerial vehicles today, they are manually controlled. So what we call that's a line of sight controlled vehicles.
Yep.
Of course, ideally what they would like to have it in non-line of sight, which is fully autonomous. It's possible, right? But the question is that how do you enable very long range detect and avoid? So these vehicles can sense its surrounding, can sense the birds, can sense power line when they take off and land, can sense holes on the ground. And for this, definitely, optical sensors are not possible. So the radar is the only one. So what you see here in that other column is our 24 gigahertz. The Polaris chip, which is the equivalent of the Marconi chip, but operates at the 24 gigahertz, which is a federal frequency for all these aerial vehicles. And all of we're sampling both of them to the customers.
All right. So this is what you have new here at CES?
Yes, absolutely. So both the Marconi chip and the Polaris chip, first time ever at CES, first time ever in history, to get to the 7-kilometer range for aerial, 1-kilometer range for ground transportation.
Okay.
And what is so interesting now, we had a press release today where we announced this contract with the Army. So the Army selected Metawave technology to enable autonomous vehicle off-road. So remember, automotive is on road. So basically you analyze transportation, you analyze operation on ground roads.
Yep.
But defense sector, they go over terrains that are not known to them. Holes, tree stumps, water pod,
They go
pods.
where, they go where they have to.
Exactly. So that's why they need a very high resolution radar that can operate at long range. Why? Because if you have monsoon rain, they still need to go operate. They cannot stop from operating.
Yep.
And that's what our chip provides, this high margin, operation margin, that even if you have high attenuation due to rain, you can still operate the radar.
Well, thank you. Thank you
Sure.
very much for the overview.
course.
It's interesting technology for sure, and best of luck with it.
Thank you so much.
Thank you,
Pleasure,
Maha.
David.